Yeah, hello guys. So this is my special. Welcome to my channel again. And please, if this is your first time you come to my channel, make sure that you click on the subscribe button. Very, very important. So today we'll be looking at the introduction to electricity. Now, what is electricity? Electricity is actually gotten from two words. You can see the word electric and also word city here, right? That means that if I divide this thing into two, I will have what? I will have electric, right? Now I have word city. Now, what is electric? Electric is actually gotten from something called what? Electron, right? Doing that now, I can actually call it also electric electric current. That means now, an electric current can also be called what? Can also be called charge. That means I can also say that in general, I can say that electricity is a branch of physics that deal with the study of the flow of electric current or electric charge into the city. So we have two scientists, that talk about like this is electricity. And the first man, so we have a lot of scientists that talk about this electricity. And the first man is called Luigi Galvani. It's called what? Luigi what? Galvani. That's his name. Now, this man experiment was talking about the fact that electricity can actually be gotten from animals. So, according to Alexander Volta actually makes some experiments. So, if you have something like this, point A and point B. So, he called this place terminal. He called this terminal, and also there was another terminal. So, he now also make another something like this, A and B also. So you now see that between this one and this one, where do you think the current will actually flow? The current will actually flow here. Why? Because what? That means because there's a potential what difference. But now, if you look at this place now, the current may not be able to flow. The current will only what do what? We only store here. So you now say that now for a current to flow, that means there must be what? There must be difference, right? That means it is actually easy for this cover marker to actually flow here faster than here. Okay, you now say that our potential difference is the work done in taking this unit positive charge from this terminal to another terminal. That is why it is what our potential difference is the what is the work done in moving a unit positive charge from one in moving a unit positive charge from one terminal of a cell to another terminal of a cell. Are you getting my point at all? So to now honor this Alexander Volta, so we now call this potential difference. We also call it what? We also call it voltage. We call it what? We call it voltage. That means I can say that voltage is equal to what? Work done over what? Over quantity of charge. Keep these formulas. The unit of this work over quantity of charge. The unit of work here is what? It is joule. While for our charge is what? It is coulomb. That's what? Joule per coulomb. So to now also honor Alexander Volta, so we can also call the unit of voltage. We can also call it what? Also what? Also volt. Are you getting my point at all? So in answer to that, now this points that is actually here and this other point, you can see that this one is what it is much longer, while this one is what it is very, very small. So you now call that means now if I pick this one out, I also pick this one out, you can see that I have two things, right? That means I can call this thing, I can call it a what? A cell. That means the longer one will be what? Will be positive, while the shorter one will be what? Will be negative. Are you getting my point at all? You can see that current does not flow here, but current will only stay here. That means we only store here. So like since we are having the same length for this one, that means I can actually draw this A here, and also like this one here, right? That means I can actually call it something. That means I will call this one cell, right? That means I will call this one, I will call this capacitor. Why? Because what it only do what? That means you can see like this one only do what? Only store charge. That is why a capacitor is a device that store what? That store charge. So that is where we get what? Our cell and also what? Our capacitor from. That means that if I want to draw my battery, battery is the combination of two or more cells. That means I can actually have the bigger one and the smaller one, right? To the bigger one to the smaller one to the bigger one to, so I mean the combination of two or more cells is called what? Is called battery. That means I can have a positive and negative, positive and negative, positive and negative, positive and negative. So this one is called what? This one is called battery. So the next person that we have is actually called Simon Ohm. And Simon Ohm was talking about the fact that if I have something like this, so you can see that the more the flow of current, the more the potential difference. That means if our potential difference is actually what is actually greater, that means our current will actually what flow very, very what faster. So this man actually is one that bring about Ohm's law. That it has that the current that is flowing through this conductor is directly proportional what to our potential difference. Again, the current passing through a metallic conductor is directly proportional to our potential difference. between the two terminal, between their what, between their terminal. So from this place I can actually see that our voltage is direct proportional to our current, right? That means that if I introduce our constant, I can say that our V is equal to what, our Ki, which is our constant. But now I can replace our K with what, with our R. And when my K is equal to what, my R, right, I can add V is equal to what, V is equal to what, I R. Are you getting my point now? Where my V is my voltage, my R is my resistance, and where my I is what, is my current. So this man actually called Andrew Ampere actually bring about something now. It bring about what, our current. And so now let's assume that these are metallic conductor. So you now see that if our conductor of electricity passing through a conductor in a unit time is actually called what, current. So that is where this man actually got what, our current from. Same as what, our my I is the what, is the rate at which the quantity of what, of charge is passing through a conductor in a what, in a unit time. It's called what, is called our current. From that place you can see that my Q is equal to what, is equal to my IT. So you can see that the first point that we talk about is what, is actually called Ligavani. And Ligavani was actually talking about the fact that our electricity can be gotten from animals. That means electricity can actually be originated from man. And the second person that we have is what is called Alexander Volta. He was talking about the fact that uh, voltage, right? That voltage is the what, is the potential difference in moving a unit positive charge from one terminal of a cell to another terminal of a cell. From that place, we actually move to George Simon Ohm. Yes, it's called George Simon Ohm, where it was talking about that current passing through a metallic conductor is direct proportional to what, voltage. Hmm? From that place, we have this equal to IR, and here we have what, we have Andrew Marie Ampere. It's called Andrew Marie Ampere. So now let's try to combine all these equations together. V is equal to what? W over Q, right? We also prove a formula that V is equal to IR, and we also prove a formula that Q is equal to what? IT. Are you getting my point at all? So from this way we can have that W is equal to what? VQ. Now this W is also called what? It's called work, and it's also called energy. So since we have work is equal to voltage times quantity of charge. Now we now want to derive also some formulas for work. Are you getting the point? Or energy. Now, since we have Q, now we have Q is equal to IT here. That means I can substitute what, Q is equal to IT into this formula. That means I can now have that what, my work or energy is equal to what? V. What's our Q? Our Q is what? It's IT, right? Our Q is IT. That means anywhere I see Q, I'll put IT. That's VIT. That means this is second formula for what? For work or energy. And like this first formula, why is on the second formula? That means I can also have another one that my work is equal to now what is my V? My V is equal to what? IR, right? That means I will put what? IR times what's my Q? My Q is still what? Is still IT. That means my work or energy is equal to what? I times I is I square. I square RT. Can you see it now? I times I square RT. And also from here I can also derive a formula for work again. Since we are given that V is equal to what? VIT. That means I can say that what is my V times, now what is my I can actually what, derive my I from here. That my I from here is equal to what, is V over R. That means anywhere I see I will put what, I will put V over R, right? That means I can say that my I times, what's my I? My I is V over R times T. That's going to what, V times this is what, it is V square. What did I have? I have T over R. That means now I generated how many formulas? I generated just one formula. The first one is what? Work is what, is VQ. Second one is what? Work is what VIT. I square RC. V square T over R. VQ, VIT, I square RT, and V square T over R. So power is equal to what? Power is work over time. Power is work over time. That's anywhere I see work, I will just put on VQ. My work is what? Is VQ over time. This is first formula for power. The second one is what? My power is equal to work over time, right? But this one is what? It is VIT over what? Over time. That means time equals time. That means I will have IV. So my power is equal to what? It's equal to IV here. And also my power can also be equal to what? My power is equal to what? Work over time. I can have what? I square RT over what? Over time. My time will cancel time. That I have what? I square R. So the last one is power is equal to what? It's equal to V square T over R. That means divided by what? By time, right? Everybody know what? Because this one is V square T over R divided by the time that is there. That's going to be power is equal to what? V square T over R times 1 over T. T cancel T. And we have what? Power is equal to what? V square over R. So these are the four formulas for power. Power is equal to what? It's equal to VQ over T. Power is equal to what? IV. Power is equal to what? I square R. And power is equal to what? V square over R. So this is the end of our video for today. Please make sure that you share this video to your friends, your families, and your loved ones. See you in the next video.